Would you now please simplify the following? I have their square root of 5 multiplied by the square root of 7, and then I have the square root of 14 divided by the square root of 7. So stop the video and try those now, please. Okay, as usual, I will now give you the answers. The first one simplifies to the square root of 35. The second one simplifies to the square root of 2. Discussion. Radicals. The square root of a term A multiplied by the square root of a term B is equal to the square root of the product of A and B. All right? The square root of a term A divided by the square root of a term B is equal to the square root of the quotient of A and B. All right, would you please simplify the following? I have here 4 cubed times 4 squared, and then 4 cubed divided by 4 squared, 4 cubed, that whole quantity squared, and then 4 to the negative 2 power, and then lastly 4 to the 1/2. Okay, so stop the video and try all of these now. Here we go. Answers. The first one simplifies to 4 to the 5th power, or 1024. The second one simplifies to 4. The third one simplifies to 4 to the 6th, or 4096 if you multiplied all the 4's together. And then the fourth one simplifies to 1 over 64. And the last one simplifies to root 4, or 2. Discussion. Here are the formulas you need to commit to memory and know very well, okay? The exponent rules, that's the topic right now. If you have a number raised to a power and then the same number raised to a different power, you can simplify that as that number raised to the sum of both of those powers, both of those exponents, all right? If you have a number raised to a power divided by the same number raised to a different power, or possibly the same even, that's equal to the same number raised to the difference of those two powers. Okay? And then if you have a number raised to a power and that whole quantity raised to yet another power, which may or may not be the same, then you can simplify that to that same number raised to the product of those two exponents. Okay? Now let me make a comment about these first three equations, these first three patterns, rules that you'll need to know. Okay? If it's not clear where these came from, what's going on, remember that exponentiation is just an abbreviation for repeated multiplication. Okay, so in a pinch, if you forgot one of these formulas, just write out what it is that that expression is an abbreviation for. Okay, for example, look at the first bullet. If you multiplied MA's together and then you multiplied the answer of that times the result of multiplying NA's together. Okay, if you can picture all those multiplications in your head, hopefully you could see that there would be m plus n factors in that expression. Okay, likewise for the second bullet, if you had a fraction with MA's on top multiplied together, and then you were dividing by the product, the result of NA's multiplied together, hopefully you could see that there'd be some cancellation going on, and so that's why. Hopefully you can see why that would give you the difference. And then likewise for the third one, if you write it out, hopefully you could see that you'd have m times n multiplications there, or m times n factors in your expression, excuse me. All right, so moving right along, a to negative m is equal to 1 divided by a to the m. Please commit that to memory. All right. And then a to the 1 over m, that's equal to the mth root of a for m equal to 2, 3, 4, etc., etc. and then a to the m divided by n, that's the nth root of a, all that whole quantity raised to the m power. All right, and that's true for n equal to 2, 3, 4, etc., etc. Right, and then what about 0? If you have a to the 0 power, that's equal to 1 for a not equal to 0. Okay? Very important, do a number of practice problems. Make sure that you've got these down cold. Okay? They show up a lot. Next exercise. Would you please simplify the following? I have -5 plus 2, 5 plus -2, -5 plus -2, -5 minus 2, 5 minus -2, and then -5 minus -2. All right. Now, before you tell yourself, oh, I don't need to do these because I already know these. I can't tell you how many times some student has told me, oh yeah, I know how to do these, of course. And then I'll say, okay, great, do this exercise for me. And then they get the wrong answer. All right. So if you really know how to do this, prove it to me. Okay. Get the right answer right now. Okay. So pause the video and try these. All right. Answers. The first one is -3. The second one is 3. The third one is -7. The fourth one is also -7. The fifth one is 7. And then the last one is -3. All right. Discussion. Ultimately, the way that you understand addition and subtraction involving negatives is you think about the number line. Okay. There'll be some tricks you will want to know to speed up this process, so you don't always have to go back to these basics, but it's important that you understand where the shortcuts come from. Okay, when you add a positive, essentially that means moving to the right on the number line. Okay, adding a negative will mean moving to the left on the number line. And then subtracting a positive means moving to the left on the number line, and subtracting a negative means moving to the right on the number line. Okay, now let me give you an example what I meant by a shortcut. Look at the last one. Notice that subtracting a negative moves you to the right, just like adding a positive moves you to the right. Okay, so you can convert one into the other. All right. If you let's say you're doing 2 minus -3, you can convert that to 2 plus 3. Okay, you'll sometimes see people explain this as whenever you see two dashes next to each other, okay, dash symbol, you can put a line through those, make them both plus. Okay, likewise, if you're adding a negative, that's equivalent to subtracting a positive. Okay, so again, make sure you do a number of examples, make sure you know this cold. Okay.